Okay, checking the microphone.
Yeah. So I'll mute myself.
Going to do a sound check here, pointing out the different parts of the color display and the measurement from the spectrometer. Here is the grease the colorimeter and put into position. Grease is here, etc. Okay, sound check. How we doing? Seem okay?
You just listening. Good. Rich, I can hear you just fine.
Okay, welcome. Welcome to the second Grease Thief Thursday, and I'm Rich Wurzbach, and I'm going to do a demonstration today on grease colorimetry. So I'm going to introduce an instrument, the Grease Thief colorimeter. I'm going to have some samples here that have been taken with the Grease Thief. Last week, of course, we talked about the Grease Thief sampling kits and how they can be used, and we're going to follow up that today with how we can start a sampling process. Now, we chose the Grease Thief colorimeter because it's a pretty versatile device. It's something that can work well in the laboratory, as you'll see me working on today, but it's also something that's fairly portable, could be used in the field. It consists of elements that are Bluetooth connected, that are wireless, that are battery operated, so it gives you a lot of flexibility where you end up deploying this technology. So I'm going to share with you here what we have as a setup. I have the Grease Thief colorimeter here. And the design of this includes a spectrometer. So this is our small portable wireless spectrometer. It has a flat panel adapter here on the top that allows us to put our grease sample there. It includes spacers. It includes this Teflon disc, which is going to squeeze out the grease that we're introducing as the sample. It also includes a dial indicator that helps us set this up. Now, the principle behind this is that when you look at grease color, it's very much a function of the thickness of the grease that you're looking at. So you could take a grease that looks very dark. It's maybe been in the machine a while, it's been aged, and it might look dark brown, perhaps almost black. And in it kind of its whole form. And then you'll take that same grease and you'll just wipe that in a very thin layer, especially on like a white background, like a clean white rag or white piece of paper. And suddenly it doesn't look black or dark brown anymore. It has a green hue or a bluish color to it. And in that case, you're going to get a better idea what's going on. So what we have found is if you truly want to measure grease color, you have to control parameters. You got to control the ambient light and how that influences what you see with the appearance of the grease. And you have to control the presentation of the grease or its thickness. In this case, what we're doing is presenting the light from behind the grease in a thin film layer, a uniform thin film layer that then gets a chance to reflect off of a uniform white surface, which is this Teflon disc that I showed, and then reflects back into the sensor for the measurement of the spectral response. So this is what we're going to be able to show you here. So I'm going to orient back to the Grease Thief colorimeter and help you get started with the process. Now, the first step of setting up the Grease Thief colorimeter is to use the spacer. And there are 4 spacers that come with it. Each has a different precise thickness. This is a tooling steel. We make them also out of stainless steel, so that's our standard now, which is stainless steel, but with a precise thickness. And this first one, its thickness is set up so that I can zero out the instrument. So the one that is marked A will be um, my zeroing spacer. Now here is the spectrometer with the securely installed the flat panel adapter, and that's going to lay here on top of that spacer. And this is going to be set up so that when I move this piece down into position, it's going to come into contact. Now, how do I calibrate that gap? Well, I do that with a Allen wrench, and there are 2 set screws here on the side. So basically, I can loosen those set screws, allow the entire assembly to sit flat. So now it's in contact, so that's 0 thickness. And then I position the handle down, and you'll see that this piece here moves up. I'm still in contact, so I'm still at 0 thickness. And this is where I can tighten those screws to set it in this position. So in the position where the handle is fully in the down position, I'm going to have 0 gap with the A spacer. Okay. So if I put any material in there now, it's going to deflect this needle. So you can see when I push this down, my needle is not moving. I'm still zeroed out. But just to make sure that that's zero, I take this very thin piece of tissue, put that in the space, and when I move that down, you see that needle moves about a thousandth of an inch. Okay, so that tells me that I've got this zeroed out. Now what I do is remove that spacer and replace it with my D spacer. And the D spacer is the smallest spacer. Therefore, when it's put into position, I end up with the largest gap. So in this position, I'm going to have 35 thousandths of an inch, which is about a millimeter. Okay, so maybe it's a little bit less than a millimeter. So now when this is fully in the down position, that's going to be a 35.0035 inch gap. And I've set my device up now to create that thickness of grease. And so I can start the process with my sample. Now here's a sample that could be taken from one of our grease thief kits. It gets stored in this protective tube, the shipping tube. I can remove the cap. This one happens to be a baseline grease. Now I'm using this today with a product called Vigo Grease. Vigo Grease is very commonly used in robot greasing for 6-axis robots, commonly used in manufacturing, auto manufacturing, that kind of thing. And this Vigo Grease is a very popular grease for that. You can see even here, its color is kind of a yellowish tan color, and that's going to be my starting point. So I can remove my grease thief cap, take this open window area here, and just dab a little bit from the grease thief right onto that surface. So the grease thief itself, the sampler, is really convenient to place a small amount of grease. And notice the majority of my sample is still retained, so it doesn't use up much grease in the process. Now that little dab that's on there, it's placed into position. And now when I push this handle down, I'm going to squeeze the excess grease out of the way and leave a thin film for this optical channel. Now I want to demonstrate a few things before I do that. First, I'm going to switch up to my standard color sensor. And this now gives me the ability to connect wirelessly. So I have this battery operated Bluetooth capability. I press on this attachment here, and it allows me to connect to my nearby sensor. And I want you to watch here. I'm not going to take a measurement, but I am going to actuate this one, and you can see that light up. Okay, so for a second there, that lit up, and you did get a response here. It really looks black because in this open configuration, that light was not reflecting off the surface back to the sensor. It was just scattering out into the room. So I want to go ahead and take a new reading, and this new reading, I'm going to make this reading with this in the down position. So before I do that, I'm going to set up my, for me is my favorite measurement mode with this device. And that is called the compare function. And now you can see on the screen in the compare function, I have two halves to this color display. And I can create a library where I can use some saved colors that I might have from historically. I've looked at different greases, and I give them in this case in our database, we give them all different numerical values, and that is a barcode scan back to what's in our database. But we can look through there, and we can either give them names or individual numbers. And the idea here is that we would match up what is the new grease that we want to compare this to. Now, in this case, this really is our new grease. So instead of using a saved color here, I'm going to select the left side, and I'm going to say scan for this. Now I'm going to move this into the down position, the grease thief colorimeter. So now I've created my 35 thousandths of an inch gap. I hit the scan button, and I've now created a baseline for that grease. That's what that grease looks like under these controlled conditions when it's new. So it squeezed that out, and it's now I'm going to have a little bit of grease here on this surface that I'm going to clean and wipe away. And I'm going to do the same thing to my Teflon block. The nice thing about Teflon is that it is a very white surface, and I can periodically do a background check so that I just get that white Teflon block response with the zero gap, and I know that I have, good clean surface here. So now I've reset my measurement, and again, this was at 35 thousandths of an inch, and I have it for that new grease. And as I look through my samples here, here's one that's coming from a robot. J2 tells me it's from joint number 2 in the position out of 6 of them for a particular robot, and it doesn't quite look the same. This grease started the same color as this, but you can see that there is some darkening here. Now, what does that darkening mean? I don't know yet, but I know it means something. What I will be able to do with this device is to create some numerical comparison to that new fresh grease. So again remove the cap here. I take the clean surface that I have, and I just push down on the handle a little bit of the grease thief, and I dab a little bit on the end. Really about 1/10 of a gram of grease is all you're going to need to do this color test, perhaps even a little less than that. The grease thief, when it's full, is 1+ grams, so we'll have plenty to work with. So now I want to compare this new sample to the old sample. I'm going to click on the right side. It's going to give me the option to scan this. So I move down into the down position on the grease thief analyzer. I'm sorry, the grease thief colorimeter. I press the scan button. I scan that, and it returns that value alongside the original one. So you can see a difference here, but more importantly, what you have is numerical values that correspond to this. And I'm using this first figure, the delta E values is 13.7. Now, is 13.7 is the delta or the difference from the new grease under these conditions. I can create criteria, and perhaps plus or minus 10 or plus 10 delta E value would be considered excessive change for this grease in this application, and I could flag it accordingly. Or perhaps under normal conditions, the grease would change even a little bit more than that. I can also see here in the details my RGB values and also the CIE lab values that you might be familiar with from doing the MPC testing. So in MPC testing, we take a white filter patch, and we pull oil through that. We pick up the color bodies from that, and we use the CIE values to say, how significant is the varnish potential for that particular oil sample. In this case, we can use the same values or RGB values, or just very simply the delta E values to create acceptance criteria. Now, both of these samples are fairly dark, but they did get well resolved at this 35 thousandths of an inch setting. Other greases we're going to find are just simply too dark, and when we would run this test, we would get a value back where very little light has transmitted through the grease. And so as a follow-up to this, if we didn't get a successful result like we did here, we do have other options, and that would include using the other spacers. So let me just clean the bottom here. And I'm going to switch spacers out now. So I take my C spacer, my D spacer, and I move back to my C or Charlie spacer. Now, before you use these, you want to kind of just wipe the surface clean to make sure there's no particulate or anything like that happen to get on them. We provide this nice protective pouch for them to keep them clean and out of the way. But, we're talking about thousandths of an inch here. So just a little bit of debris getting in there could be problematic to that measurement. So now I put this one in. This is a little bit thicker than the D. The C now leaves me a gap relative to my original setting that is 10 thousandths of an inch. So when I bring this, if I put the spectrometer back in place, set that there. When I bring this down now, that's going to gap the grease to 10 thousandths of an inch. So for these darker greases, I can now do a comparison. I want to make sure that my comparison is consistent. If I'm going to test my in-service grease at 10 thousandths gap, I also want to be testing the new grease at the 10 thousandths gap and create the delta T criteria based off of that. There is another spacer here that can take it all the way down to 5 thousandths of an inch. So I can go 35 thousandths, 10 thousandths, and 5 thousandths. And these are the points at which I make those measurements. I get my delta E values. I can create criteria against that. Now I can use this to decide, has the grease changed? And we think for a minute, what kind of things can cause that grease to change from a color perspective? And one of the things could be wear, just the accumulation of wear. So we like to see this device married up with a wear detection device. And what we have planned for next week is going to be the FerroQ device. The FerroQ device is a quantifier for ferrous debris designed for the grease thief, where we can take the grease thief, drop it right in to a coil, an induction type coil, and it's going to have a response proportional to the amount of ferrous debris that's present. So if you take the ferrous debris and you know what's going on from a wear perspective, and you take the color and you can look at what's happening with the grease or perhaps contaminants or the aging of the grease, you get both halves of that picture. So when the color changes, we can also look at, especially if we look at the CIE values, we can say, are the hues changing, or is the L-star value, which goes to the darkness or lightness of the grease? And sometimes the color is near the same as it was when it was new. It's just gotten darker. It's more attenuation of light. And this would tend to correspond to the aging of the grease. Versus someone came along with the wrong grease. It was a blue grease and they put a red grease in, and now you see a hue shift, and we can pick that up as well. So there's a lot that we can extract out of this grease analysis from a color perspective. We can't answer the question specifically what caused that or what is the nature of the color change, but we know we can get to the point where we can create criteria and then say, hey, this grease still looks good. It's following the typical profile of this application, of this grease in this application, and it's acceptable. We don't have to go further with this, especially if we check on the wear side and the wear looks good as well. Or we can say, hey, this grease is changing. These are the handful of grease samples that we want to screen into our program to do more analysis to find out what is causing that color change. And that's where we can go to FTIR analysis, looking at whether the peaks really match up to the type of greases there, whether there's oxidation taking place, whether there's contaminants present that could be responsible for the color change. And so I've got some greases here, and you may have seen in an invite. Now I'm really out of focus, and I've got to learn how to get these back in focus. That looks a little bit better there. So these are a series of, it wants me to really hold that still. These are a series of greases that are all of the same type. They're all of this Vigo type grease. They're coming from robotic applications. And you can see we can go from an extremely light grease here that looks very close to, what our baseline grease looked like, to something that almost looks black. And I apologize for the focus there. I thought that might come in a little bit better. But we can then, use that to screen out these samples. And the presentation of the greases here was done from the die extrusion process. So again, I'm going to try to orient this around here to give you a look at our grease thief analyzer. So in the grease thief analyzer, we're extruding the grease out using a die extrusion process. So you've got your grease thief here, you've got some red grease in here, and here's our extrusion die. That's going to go into this part of the analyzer. We're going to have our plate here with the plastic substrate. The grease is going to squeeze out onto that surface, and a couple things are going to happen out of that. One is that we're going to measure the force of extruding the grease and compare that to the new grease to get a sense of the consistency. All with 1 gram of grease, we're going to be able to tell consistency. Has it increased or decreased? Has it gotten softer? Is it shearing? Is there more solids in the grease that's causing it to thicken up and be harder to extrude? We're going to have numerical values for that again, we can create criteria for and judge whether that grease is suitable for continued service. Out on the substrate, this is what I wanted to show you is what is here on the table where we had these different colors of grease, and we can look at those. We can take those individual samples and do additional analysis. FTIR, we can look at the ruler values and measure the antioxidants. We can look for other indications of contaminants getting in the grease. We can look beyond the ferrous wear at that point and look at the non-ferrous, look at the additives. Maybe there's been a mixture with other greases or other substances or materials that might be present in your plant. And as we go through our series here of these Grease Thief Thursdays, we'll also get into particle counting, and you can see the camera here that allows us to watch this substrate as it comes by, size, count the particles, and give a sense of the cleanliness of that sample. So this is a versatile setup back to the colorimeter. And of course, our primary goal in this is creating a capability of measuring greases. But there's some other things that you can do once you have this device. And this adapter can be used with a liquid cell. I'll show that a minute here. So this liquid cell has an optical window. It's a sandwich cell. So we can pull this apart. We can put a drop of oil or coolant in here, slide that into this drawer, and we now have a surface and a presentation with a white reflection background where we can put that same colorimeter right on that and measure the color of that defined thickness oil or grease, oil or coolant, maybe even fuels. And we've got some folks doing that as well to great effect. So again, you could start with what your new coolant looks like, and it might be a kind of a greenish yellow dyed coolant. It might be dyed pink. We've been doing coolant testing for some folks, and we've actually seen the colors start to shift because one type of, say, ethylene glycol coolant was supposed to be used, and a propylene glycol, which has a different dye base, was mixed in there or topped it off, and you start to see the color change. So you can pick that up and use the same software interface here to be able to compare what does the new coolant look like versus my in-service coolant. Does it just get darker? Is it a sign of perhaps corrosion in that coolant system? Is it a sign that it's been topped off or mixed with different coolants that have different color profiles to them? And then the oils. And, one of the tests that's out there doesn't get done a lot, maybe on a regular basis, but it's the D1500 test, which allows us to compare the aging of oils. And a lot of our oils, mineral oils, will start with an amber type color, and they're going to change over time, perhaps in response to darkening, mixing, aging. It could be from contaminants, it could be wear accumulation. And there's that kind of 1 to 10 rating on the D1500. Well, you can create criteria for that. In fact, you could put the reference charts right under the spectrometer to see what the response would be, RGB values or CIE values, and then make it so that you can take those exact measurements. So now it's not a matter of someone having to hold up a sample of that oil and look at a handheld chart, which, by the way, can get dirty over time, can get exposed to light and change and so forth. But instead, you're going to make a direct measurement and from that create criteria to say which bin do we put this in from an analysis standpoint. So greases, coolants, oils, maybe even fuels, all that's possible here with the Grease Thief colorimeter. But the primary use for us is in testing the color of greases. And what you'll hear sometimes is that grease color doesn't matter. Grease color is just, something that the manufacturers put in there maybe to help us know we're using the right grease. Sometimes I think it might be kind of a marketing thing. I saw one grease in a magazine and it said, look at this cool blue grease. It's going to keep your machine cool. Almost like there's a bit of psychology going in there on how they choose what dye they're going to use to market that grease. But once that has been done and we have this starting point, we have this palette of greases that range all over the place. now we can use that to our advantage. We can go back and say, yes, these 4 or 5 greases all look like blue greases, but when we look at them carefully in their spectral response, they're not. Your RGB values or your CIE values, A star, B star, and L star, might be very different, but to us, they just look like blue greases. So we get this chance to really numerically and from a criteria perspective, identify what our starting point is with these greases. And then as things change in service, we can say, what has happened here? Is there enough that we need to pick this up and look at it differently? And you might say, well, how did we ever get to this point? Well, we've been doing grease analysis here for I guess about 10 years now. And in the early days, I would get, it was kind of a lot of hit and miss. And, you're hoping someone would send you a sample to try out techniques that you've developed and so forth. But customers would sometimes say, hey, I'm going to send you some grease samples because they just don't look right. And I felt, there's something valid there. Someone is used to seeing a grease, using a grease in an application. They know what to expect. They know their machine. They know their application. And to them, it just doesn't look right. They can't put a number around it. They can't be specific about it. I had another example where we were working with, in our area here in York, Pennsylvania, we were working with a company that does servicing for robots. And we asked them for the opportunity to go with them on a service call and take some grease samples so that we can bring them back to the lab and analyze them. And the young fellow that we were with that day, we went into, I think it was 8 different robots that day. We were able to take grease samples. And at the end of the day, I said, hey, I'm going to take these back to the lab. I said, we're going to analyze them and I'm going to share the results with you. And he turned to me very confidently and said, yeah, you're going to find problems with robot 3 and robot 7. I said, really? You already know that? Have you been measuring something else on these robots? And he said, no. But just by the way the grease looks, I know we're going to find a problem in those 2 robots. And I said, what do you know? What do you see? He says, I can't tell you what it is. He says, when I see it, I know it. So at that point, this is a guy that's been working on these assets for a long time, and he's been able to equate something visual, some visual indication with what he finds when he tears that machine apart. And I said, we somehow have to capture what this gentleman is seeing and give us all the capability to be as good as Ben with his robots. Give us all the capability to come up with some kind of numerical value that we can use and create a trend or create an expected value. And when we get out of that, then we can say there's something not right here. Just like Ben being able to say something wrong with robots 3 and 8. But now we can do it with a measurement. We can do it with criteria. We can do it with values that we can generate with the grease thief colorimeter. So that's what I wanted to share with you today. A little shorter presentation than we had last Thursday. Sometimes we'll try to use most of the hour. Sometimes we'll just get right to the point and put it out there for you. But for those who have joined us today on the Samba version, I'll put it out there to see if there's any questions. And I think one problem is I have is that I can't hear this. So I'll have to ask someone in my lab here to shout out and tell me what I need to respond if there are any questions. Yeah, okay, good question. So in the background there, Richard Janoski just relayed Mindy's question, and we've done 2 things today. We simulcasted this in YouTube, so I believe we're going to be able to go edit that down and to have a YouTube equivalent. But also, we've saved this as within this Samba video conferencing, and we'll convert that into, I guess we would convert that into YouTube as well. So here's what we're going to do, Treg. We're going to get the folks that participated today, and even those that weren't able to join us, and we're going to send them out a link. And we've been using the newsletter service, the My Newsletter Builder, and hopefully folks are getting that. If you're not, let us know. We'll send you a direct email with that information, but we'll give you a link. Most likely it'll be a YouTube video that you can go see at the conclusion of this. Good question, Mindy. Thank you. Anything else? Well, folks, thanks. It's exciting to be part of grease analysis and developing these new tools, these new techniques, and hopefully next Thursday we can roll right into a demonstration of the furrow Q, looking at the capabilities that we put together there in measuring precise, repeatable, and reproducible ferrous levels for grease with the 1 gram sample that you get out of the grease thief. And I hope to see you back next Thursday for that, and each Thursday here for a while as we continue to share what we're doing in the world of grease analysis. Thanks.